Greetings. Some of you have probably been wanting to work on a couple of electronics projects where you're going to fix something, and I've been researching things, and one thing that, you see the sticker on the side of the TV that there's dangerous voltage and things like that, and one thing you're going to want to watch out for is the capacitors that are going to store sometimes a lot of energy, sometimes enough to maybe injure you, sometimes enough to actually really injure you. And with these capacitors, what you're going to need to do is discharge them before you actually start reaching around and doing a little bit of testing under no power. Now, here's a simple solution. It is 2 chopsticks with a simple circuit on one side that has an LED to let you know that you have gotten a charge from a capacitor. And then the other side, it's linked in just to short it across to this. And what the circuit actually is, see, we use chopsticks because wood is a nice, really good insulator. Then we get down to the end here. We actually have a parallel circuit where we have a 2K 3 watt parallel with a 2K 3 watt resistor, and then I have a blue LED series with a 440 quarter watt resistor up at the top. This ends up being 305 ohms with this, and this, and then when you add the calculated LED from what I got from the data sheet, you get around 484 ohms. The way that this ends up working is your LED is going to turn on for a brief second, and then the rest of the power is going to rush through here as the capacitor discharges. It's not going to look like your light stays on or anything. It's not going to be a huge bright show, but it's going to just barely tense up, and it's a lot better than if you were to take a screwdriver and short across it and possibly get some sparks. Now here I drew a little capacitor. If you see, you have that stripe that has the negative signs. That's the negative leg of the capacitor. The one that has nothing is the positive leg. On here with the diagram, you see I have the circuit on this side with the LED and the parallel resistors. And then I have a little brass probe that I machined. And it's all taped up here with a wire coming off it with an alligator clip that clips onto an L-shaped brass piece that's on the other chopstick that we're going to touch to the negative side of the capacitors. The alligator clip is to maybe clip to ground, just out of convenience. So I have a couple things I was drawing up just to figure everything about it while I was planning it out, and let's check it out. The test we're gonna run here is I actually have a capacitor which is a 220 microfarad at 250 volts. It can handle quite a bit of voltage. And what we're going to do is we're going to charge it up, and then we're going to use our little tool here to discharge it and see what it looks like. Okay, we got our DC power supply charged up. Our alligator clips for that sitting right here, and our chopstick tool as per the circuit shown. Let's dock this so we can kind of watch. So we can get this stay. Alright. Now, if you take and charge up the capacitor for just a little bit of time, you'll see the voltage dip for a minute second. It doesn't take much to charge a capacitor. So, we'll just let it sit and take it off. And now, I am going to, let's see if I can get this in this frame. There's that. See it flash? You hold it, touch it again. Now, the thing about this is, it's not gonna, the LED is not gonna stay on because most of the current's gonna rush through it, those 2 other parallel capacitors. So the LED is just going to flash to let you know that you hit a spot that has some voltage. We can illustrate that probably better if we take and put our DC power supply leads down here. And see if I can get them to stay. We get these down here and actually test those. Now if I put my negative on here and then touch the positive, it flashes and it's still got power, but it turns off. Now if I touch it multiple times, move away so you can kind of see it. Yeah, it flashes every time I actually touch it, but it goes off immediately. And if you look at the amperage on the power supply, the amperage is actually up at about a half an amp to 1 amp, depending where I have the voltage set. So it's going to do that. You hold it for a second and then touch it again, make sure that the voltage is off. If you touch it again and it flashes, hold it for a little longer and then touch it again, just to make sure that you can see there's no more voltage in it since you've shorted it together. This is to prevent electric shock to you and make sure that while you're working in the cabinet, things accidentally don't happen. Now there's also other things inside of, like, say a TV, like the old tube TVs. The tube will hold a lot of voltage and it will process some current right through you. So you should really look into what you're working on and see what the dangers are before you start working on it. But this is nice because it has a complete insulator as the handle with the chopsticks. And it has a nice little circuit to make sure that you dissipate most of it across to the negative lead. And you have enough to just barely power this LED to show you that there's still voltage in it. Now the reason I did that is to make sure that once you have touched it for a second, you've drained it all the way. If you didn't have the LED, when you touched it again, you wouldn't know if there was more than, say, 2-3 volts of voltage left in the capacitor. There shouldn't be, but, you know, better safe than sorry. So, that's another little idea that I had watching other people do things as to make like a standardized thing that I was going to do it with. Enjoy. Feel free to use it. Find a better way if you got it. This is Chase Kennedy. Thanks for watching.